Yes, once again, good day, my fans out there. I remain Dr. D.I. June, your chemistry lecturer on social media. I've been discussing on the various states of matter. Matter is classified into three: the solid, the liquid state, and the gaseous state. In our previous lectures, we have discussed intensively on the solid state, also on the liquid state. And we know that matter per se is any substance that has mass and occupies space. And I told you that matter is made up of particles, tiny particles, which we call molecules or particles or ions, and that these particles are in a continual motion. That is the kinetic theory. But when we classify matter into solid, liquid, and gas, we discover that in the solid state, the molecules or the atoms, so to speak, are so held tightly together that there's no free movement that can be exhibited by these molecules or atoms. And that force of attraction is called the force of cohesion. Could be ionic, could be equivalent or covalent. And because of that, solids have definite shape and size and volume. But in the case of a liquid, as we discussed previously, there are some spaces between the molecules or atoms. And therefore, there is opportunity for these molecules to move about. So when they are agitated by that temperature or whatever, they can vibrate, they can rotate, they can also move either to the north, to the south, east, or west. And that slow movement makes liquids to have volumes, but not definite shape. But liquids can take the shape of any container where it is placed. Now, the final state of matter is the gaseous state. The gaseous state. Now, let's briefly talk about the gaseous state. The particles that are in the gaseous state are relatively far apart. If you compare it to liquid and gas, they are far apart, very far apart. And therefore, they have more kinetic energy than those in the liquid. Let me give you an example. For example, if you're in a classroom lecturing or teaching, and maybe a student pollute the air from angle 90 somewhere else, within a twinkle of seconds, everybody in that rectangular room or square room will begin to perceive the odor. Why? Because the molecules move very fast enough. So within a few seconds, everybody can perceive the odor. Now, the cohesive forces in a gas are negligible. In the sense that as if there is no force holding the molecules or the particles together. Because if there were any force, at least there would have been a restriction in their movement. But the movement is so rampant that we feel there's no force of attraction holding them. That's why we said the force of attraction is negligible. And the particles are free to move about in all directions at a very great speed. Very great speed. That's why even if somebody is burning something somewhere far from, because it is in the air, you can receive it and perceive it where you are within seconds because of the great and fast movement of the molecules. A gas has no definite shape, just like liquid. A gas has no definite shape. We have different types of gases. If you go to organic chemistry, you have them. In the physical chemistry, you also have them. Carbon 4 oxide, carbon 2 oxide, hydrogen 2 oxide, neon, argon, all these are gone. Krypton, they are all gases. Hydrogen is a gas. Chlorine is also a gas. All right. Now, because there is no particular force that is understood to be holding them in position, you can easily compressed gases. If gas is contained in a container, you can decide to press the lid down and you can compress them. And compressing them will bring about an increase in pressure. Increase in pressure. Because as they are contained in the container, whether you have decreased it or not, they keep on bombarding the walls of the container, bouncing back, bouncing front, colliding among themselves against the wall of the container, just randomly moving. So if by reason that they begin to press down the lid or the cover and reduce the volume of the gas in that container, then it means that you are reducing the space per se among the molecules. And there's a tendency of the molecules to collide frequently more than before. And when that happens, the pressure has increased. So, like it, comment, and follow me for more lectures. Also, go to my YouTube channel and download. Thank you.